In this video I'm going to be looking at the solution to question 1 of the January 2011 Edexcel M1 paper. The topic of the question is momentum and impulse. So we're told that two particles B and C have masses m and 3 kilograms respectively. They're moving towards each other in opposite directions on a smooth horizontal table. The two particles collide, and immediately after the collision the speed of B is 4 meters per second and the speed of C is 2 meters per second. Sorry, that was immediately before the collision. In the collision, the direction of the motion of C is reversed and the direction of the motion of B is unchanged. Immediately after the collision, the speed of B is 1 meters per second and the speed of C 3 meters per second. So we're asked with that information to find the value of m, which was the mass of particle B, and the magnitude of the impulse received by C. Well, first of all then, putting this information onto a diagram, we have B of mass m moving at 4 meters per second in one direction, and particle C of mass 3 moving with a speed of 2 meters per second in the opposite direction. That's the situation before the impact. Afterwards, we have that B is moving in the same direction as it was initially at 1 meter per second, but the direction of C has changed and it's now moving at 3 meters per second. 3 meters per second in the opposite direction. So conservation of linear momentum, gives it the momentum before impact, 4m minus 2 times 3 giving us 6 minus 6, because that's in the opposite direction, is equal to the momentum after impact, which is m plus 3 multiplied by 3, so 9. So that's the statement of the conservation momentum. This evaluates to give 3m is equal to 15, and therefore m is equal to 5. And that, of course, is kilograms. In part B of the question, impulse is equal to change in momentum. Now we're asked to find the magnitude, so impulse is affected, but it doesn't really matter which way we do this, in which direction we do. So the impulse, the final momentum of C is 3 multiplied by 3. The initial momentum was 3 multiplied by negative 2. So the change, that's the final momentum minus the initial momentum, and notice the negative in there because the initial momentum was in the other direction. So the magnitude of the impulse is equal to 9 plus 6, which is equal to 15, and that would be Newton seconds. The marking, there was an M1A1 for getting the conservation momentum equation correct, and another A mark for getting the value of m equal to 5. The method mark for looking at the change in momentum for the impulse, and an A mark for the value of 15. So that's the end of the solution to this question. Solutions to other questions can be found at www.furthermaths.org.uk.